All right, so this is what we're referring to as skeleton notes. Nathaniel, do you have those? Okay, come on up and grab some. So anytime I have materials for you to pick up that day, if you want to go ahead, if they're up here on the front, you'll go ahead and grab them. If there's nothing up here when you walk in, that means we're probably doing something else that day. All right, so we're going to be doing a little bit of review. These first like 3 or 4 weeks are going to be stuff that you would have learned in Algebra 2. So I do apologize if it's kind of boring, because I know math never gets boring, right? Yeah, all right. So if you already know this material, it's just another opportunity to go ahead and revisit it. But it's also good because maybe you got out of Algebra 2 with some holes or some gaps. This is a perfect opportunity to go ahead and fill those in. Go ahead and get some help. So we're going to start with relations and functions, just a little bit of review. The next lesson goes into it much deeper, but today is really going to be about intersections and unions. We're going to be talking about some sets. So if everybody's set, yeah, I can already tell it's going to be awesome. Okay, so let's see, relation. Any set of ordered pairs of numbers. So any graph, any equation you've ever come across, right, Nathaniel? Right, Nathaniel? Okay, head up, please. They are considered relations because they are all created using these ordered pairs, these coordinate points, x, y. Now, in pre-calculus, we have specific terminology, vocabulary, and we also have symbols we use for notation that I'm going to want you to know. So the first one being abscissa. It's the first coordinate of an ordered pair. So really that's the fancy way of saying it's your x value. It's an element of your domain. While an ordinate is the second coordinate of the ordered pair, so that's an element in your range. So an abscissa is the x value, an ordinate is the y value, okay? Now range is the set of all ordinates of a relation, okay? Now function, a relation such that no abscissa, what's abscissa again? That's the x value, is used more than once. Now, this is how you were taught way back in the day. A function is anything where no value of x repeats. Very good. And one way we looked at that was visually with what we call the vertical line test. So if a vertical line intersects, okay, so here's the symbol for intersection. It's a capital upside down U. A relation more than once, okay, this arrow pointing to the right, what does that mean? This implies. Okay, now sometimes you might see it as a double arrow. You might see it, like that. Okay, does anybody actually know what it means if the arrow is pointing in both directions? Okay, that means is equivalent to. Okay, is equivalent to. That shows equivalency. All right. The relation has an abscissa, an x value, used more than once. So what do the 3 dots in the triangle mean? Therefore. So I've made my statement, and then here's my conclusion. Therefore, the relation is not a function. And your earlier teachers probably referred to this as the pencil test. Okay, where you took your pencil, you just moved it across your graph, maybe even used your finger. Okay, but if your vertical line touches your graph in 2 or more places at any time, not a function. It's always going to be considered a relation, but it may or may not be a function. Now, let's talk about intervals. Okay, the set of real numbers between any 2 reals, or a real value and, what's that, positive or negative? What's that sideways 8? Infinity, okay. So does infinity represent a specific number? No, it's an idea. That means it's just continuing to grow or decrease. Okay, whatever sign you have. So it may or may not include the ending real values. Well, back in Algebra 1, more than likely you went ahead and used your inequality notation. So let me give you an example. Just a simple line graph, something like this. So let's say I have 5, open circle, I'm going to shade to the right. Just a simple line graph. Okay. So what values of 5, or what values of x, should I say, am I interested in here? Okay, now in rotation we're talking 5 to infinity, but in terms of inequality. I'm going to put x, I'm going to put 5. Are we talking less than, greater than? Greater than, do we have equality? We do? Why would I not have a bar below that? There you go. So that indicates whether or not 5 is included or not. So here, because it's an open circle, I know 5 isn't part of the answer. Now, we can get really close to 5, maybe 5.01, but we can't take 5 itself. If it was a closed circle, then we'd have equality. And this is what I'm really interested in. We now want to go ahead and take this, what you started doing in Algebra 2, and rewriting it in what we call interval notation. Interval notation. And somebody already mentioned it. What are the 2 symbols we have with interval notation? Okay. One of them is what kind of? Oh, no, that's inequality. Okay, not a union, but we can use it with such. We use these, what do we call them? Parentheses and brackets. With interval notation, we describe these using parentheses and brackets. What's the difference? That's exactly right. So the brackets would include the value you begin or end with. So that means the parentheses would be an open circle, so they would not include. So in this case right here, my lower boundary is 5. For interval notation, we always separate the values with a comma. We always go from left to right like you're reading a book, from smaller to greater. Now, what's the upper boundary here, or how high do we go? Positive infinity. Okay. So what did we say, was the 5 included or no? It is not, so I'm going to go ahead and put a parentheses. Do we ever include infinity? We do not, because infinity doesn't represent a specific number. It's an idea. Okay. Do I need to give you a couple more of those, or do you guys remember that? Does anybody want a few others? No? Okay. Well, good. That's what we're going to be using in here. All right, so we're going to go ahead and switch gears a little bit. Let's start talking about sets, specifically intersection and union. So a set is a collection of things. So it could be a collection of numerical values, could be variables, whatever it is. Okay. Now, we have 2 main ideas, the intersection and the union. An intersection, it's the set of common elements from 2 sets. If you're looking graphically, it's the overlap. You're looking for what's in both sets. What do they share? Okay. The symbols we have is the upside down U. That means intersection. But they could also use the capital upside down V. So they could use those interchangeably. Both of those are referring to intersection. All right. Now the union of sets is the set containing all elements from the 2 sets. I like to think of this as a marriage of the 2 sets. You're going to take everything from one, everything from a second one, and you're going to combine them into a brand new set. Okay. What are the symbols we use here? A capital U or a capital V. We can also refer to these as conjunction and disjunctions, and I'll elaborate more on that in the coming days, but we don't have to worry about it right now. Let me give you an example. Let's say set A is made up of elements, get this all right, 2, 4, 6, 8, 10. And let's say set B is going to be 1, 2, 3, 4, 5. So let's say I have 2 sets, just to kind of give you the basic idea. Now it can get, a little more complicated than this, but we're going to start off at the basic level. Right, Nathaniel? Right, Nathaniel? Right. All right. So let's see here. What if I were to ask you, given these 2 sets, A intersecting B? That's exactly right. The intersection is to see what's in set A that is also in set B. We have 2 and 4. That's the only thing in common. So the intersection of the 2 is just this right here, 2 and 4. What if there are no shared elements? Is it possible for that to happen? Yeah. So what happens if that's the case? No solution. Okay, we call that the empty set, the null set. Or you could go ahead, like Brandon said, use no solution. That could be perfectly fine. Now, what if I were to ask you this? Okay. Now, don't let the fact that I use the V instead of the U worry you at all. What does the V mean? It's the union. So how did I describe the union? It's a marriage. I want to take every element that's in A, and I want to create a set with every element from B. Now, what happens if there are shared elements? Do I have to write those twice? No, I don't. So if they repeat, I don't have to worry about writing them twice. So can anybody tell me what's the union of A and B? you go. That's exactly right. Okay. Now, we're already going to have our first quiz this week. I believe it's coming up on Thursday. I need to check the website to be sure, but all I did was put intersection, union, complements on there. That's coming up on Thursday. Okay, so nothing huge. All right. I do want to go ahead and mention while I'm remembering it, if you have taken a look at the website, and I've got it on the board over here, next Thursday, the 30th, that's when you're going to have your first test. Okay, so anything basically from the first day of school to that day, anything is fair game. But, typically the week of the test, like on the website, I'll tell you specifically, what items you want to look at in particular so that you can be more successful. Just be listening in class. I'll talk about it. But quiz this week, test next Thursday. And this quiz I may have to move to Friday. It just depends on how far we're able to get. Okay. Oh, and before I forget this as well, if anybody's interested, not only do I have the website, but I have a remind text that I've set up a little for your class. It's right there in the middle, Pre-Cal Academic. You don't want IS. So if you want to sign up for that, it's at, what do we got here? G7G Cha. G7G Cha Cha Cha. Hey, and it made an A, so the board's getting into it too. Okay. Cool. So I'm going to be sending out a practice text today. So anybody that signs up, if you don't get a text from me, just let me know. We'll figure out what the problem is. But, it'll be just something to help me with you. If there's something I forget to mention in class, or if something's got to change, when a quiz is, when tests are going to be, that it's just another tool I can use to reach you. Okay. All right. Well, there's a couple of other symbols I want to talk to you about. The curvy E is an element of or belongs to. Okay, so like if I were to have set A is equal to 159. Okay, would it be a true statement to say that 5 belongs to set A? Yes, and that's what we're saying. That's what that symbol means. It belongs to or is an element of. Okay, now these sideways used, these are what we call a proper subset of. Okay, and you'll see a better example of one in just a second, but we have a proper subset. If it has the bar below it, that's the same as equality. So it's a proper subset or is equal to. So can anybody describe to me what a subset is in your own words? We got it here at 36, right? Okay. Yeah, just what a subset means, either one. Yeah. It could be equal to that group, but what if there's no line? Yeah, what if it's just a subset of? It can't equal that. Think about it this way. The best way to describe it is a group within a larger group. That's what we call a subset. So the group can equal itself. Think about this analogy. We're the only students in this entire school who belong to 5th period pre-calculus academic, right? We form our own group. Okay, but this group still belongs to a larger group of the school. We're all Westerners, right? So by the math definition, we would be a subset of Lubbock High because we're a group inside of a larger group. Does that help to kind of make sense? Okay, and I've got an actual set coming up here in just a second, but here are the symbolic definitions. So help me out here. What does the U mean? So the union of sets A and B is equal to all X, so all the elements. And does anybody know what that colon is? It's 2 words. Okay, it refers to such that. All right, so what you have here is you say all elements that we're calling X such that, and then whatever follows is specific instructions. It's like restrictions on the value. Okay, so this reads X belongs to set A. Now, is this one and or? Okay, this one's or. So union is or, intersection's and. There we go. So this is or X belongs to B. Now, instead of the colon, does anybody know what we can use in place of it? Because you don't always have to use a colon there. Anybody remember from Algebra 2? No? That's okay. That's okay. It could just be a little vertical segment. So typically you'll probably see it as a colon, but if you see that little vertical slash, that still means such that. So this is the intersection of sets A and B. It's all values of x such that x belongs to A. What? Is it and or? And, because that's the intersection, x belongs to B. Okay, so remember, you see these symbols, that's and, that's the intersection. Those are or, that's the union. Okay. All right, good, good, good. Okay, use set notation to write the elements of each set, then determine whether the statement about the set is true or false. So we'll probably get to one or two of these, and then we'll go ahead and finish this up tomorrow. But just to kind of give you an idea, it says n is the set of whole numbers greater than 12, but less than 16. Okay, so let's start here. Okay, what would be the first element of this set? 13. Okay, now I heard 12. Which one would it be, 12 or 13? It would be 13 because it does say greater than 12, right? So the next whole number would be 13. Now, how far can it go? Only to 15 because it says less than 16. 13, 14, 15, right? Now, is it fair to say that 15 belongs to set N? Yes, that's a true statement. So that would be true. Okay. Is everybody okay with that? Any questions? Okay, so we're going to go ahead and stop there because I got 12:34. Guys, you did a fantastic job today. I want to thank you very much. We'll finish this when we come in tomorrow, talk about a few other things, and see how far we get.